Python Pandas versus Excel. Why Pandas wins. Welcome to Urban Flow Lab. In this video, we are going to explore why Python Pandas is the superior tool for data analysis compared to Microsoft Excel. Whether you are a data analyst, an engineer, or just someone who works with data every day, this video will show you why making the switch to Pandas can transform the way you work. Imagine this. You have a spreadsheet with 500,000 rows of data. You open it in Excel and immediately it starts to slow down. You try to run a VLOOKUP formula and the program freezes. That spinning loading wheel appears and you wait and wait. 10 minutes pass before you get your result. Sound familiar? If you have ever worked with large datasets in Excel, you know this pain. But there is a better way. What if you could load that same data, run your calculations, and get your results in under a second? That is exactly what Python Pandas can do. So what exactly is Pandas? Pandas is a free open-source Python library designed specifically for data manipulation and analysis. It was created by Wes McKinney in 2008 while he was working at a hedge fund and needed a better tool for financial data analysis. The name Pandas actually comes from panel data, a term from econometrics referring to multidimensional structured datasets. Pandas provides two main data structures. First, the series, which is essentially a single column of data, like one column in a spreadsheet. Second, the data frame, which is a full table with rows and columns, just like a spreadsheet but far more powerful. It works on Windows, Mac, and Linux, and because it is open source, it is completely free to use. Let us start with the first major problem: file size limits. Excel has a hard limit of 1,048,576 rows per worksheet. That sounds like a lot, but in the real world it is not. If you work with sensor data, transaction records, or any kind of time series data, you can easily exceed this limit. And when you do, Excel simply cannot open the file. Pandas has no such row limit. It can handle hundreds of millions of rows, limited only by the amount of memory on your computer. To put this in perspective, we regularly work with datasets containing 5 million rows of sewer flow monitoring data. Excel cannot even open these files. Pandas loads them in just a few seconds. Problem number 2, speed and performance. When you write a formula in Excel, it recalculates every cell one at a time. With a small dataset, this is fine, but with hundreds of thousands of rows, it becomes painfully slow. Pandas works completely differently. It uses something called vectorized operations. Instead of looping through each cell individually, Pandas applies calculations to entire columns, at once using highly optimized C code running under the hood. The result, filtering 1 million rows in Excel, can take several minutes. In Pandas, the same operation takes about 300 milliseconds. That is roughly 600 times faster. This speed difference becomes even more dramatic as your data grows larger. Problem number 3, reproducibility and automation. Think about how you work in Excel. You click on a cell, type a formula, copy it down, maybe apply a filter, sort the data, create a pivot table. Every step is manual. Now imagine your manager asks you, how exactly did you get this result? Can you show me the steps? In Excel, that is very difficult. You would need to remember every click, every filter, every formula you applied. In Pandas, every single step is written as code. You have a complete, readable record of every transformation, every filter, every calculation. You can run the exact same analysis again in seconds on completely new data. You can share your script with a colleague, and they will get exactly the same result. This is what reproducibility means, and it is essential for any serious data work. Problem number 4, error-prone manual work. Excel is notorious for introducing errors, copying a formula and accidentally getting the wrong cell reference, overwriting data without realizing it. hidden errors lurking in merged cells. These are not theoretical problems. One of the most famous examples is the Reinhardt and Rogoff economic study published in 2010. A simple Excel error, where certain rows were accidentally excluded from a formula, led to incorrect conclusions that influenced global economic policy for years. In Pandas, your original data is never accidentally overwritten. You load your data into a data frame, perform transformations on copies, and save results separately. The original data file remains untouched. This separation between input data and output results is a fundamental principle of good data practice. Now let us look at what Pandas can do that Excel simply cannot match. First, it can read almost any file format in a single line of code: CSV files, Excel spreadsheets, JSON data, SQL databases, Parquet files, and more. Second, it can merge and join datasets together just like SQL joins, combining data from multiple sources effortlessly. Third, it handles time series data beautifully with built-in date-time indexing and resampling. Fourth, group-by operations across millions of rows happen instantly. Fifth, you can reshape your data with pivot tables entirely in code. Sixth, data cleaning becomes straightforward, removing duplicates, filling missing values, standardizing formats. All of it can be done in just a few lines. And finally, Pandas integrates seamlessly with visualization libraries like Matplotlib and Seaborn to create publication-quality charts. Now, let us be honest, Excel is still a great tool, and there are situations where it is the right choice. For small datasets under 10,000 rows, Excel works perfectly well. For quick one-off calculations where you just need a fast answer, Excel is convenient. When you need to share results with non-technical colleagues who need to view and edit the data themselves, Excel is the natural choice. And for simple pivot tables and charts that you need to create quickly, Excel does the job. Pandas is not always the right tool, but when your data gets large, when your analysis gets complex, when you need to automate and repeat your work, or when accuracy and reproducibility are critical, then Pandas is the clear winner. Getting started with Pandas is easier than you might think. First, install it by running pip install pandas in your terminal. Then, at the top of your Python script, import it with import pandas as PD. Loading data is as simple as writing df equals pd.read_csv and passing your file name. From there, you can filter rows, calculate statistics, group data, and save results, all in just a few lines of clean, readable code. If you already know basic Python, you can learn the fundamentals of Pandas in a single weekend. And once you do, you will wonder how you ever managed without it. So let us summarize why Pandas wins. Number 1, no row limits. Handle millions of rows without breaking a sweat. Number 2, lightning fast. Vectorized operations make Pandas hundreds of times faster than Excel. Number 3, fully reproducible. Every step is code, so you can rerun and share your analysis easily. Number 4, less error-prone. Your original data stays safe while you work with copies. And number 5, more powerful. Advanced data manipulation, multiple file formats, and seamless integration with the Python ecosystem. Remember this: Excel is a spreadsheet tool. Pandas is a data analysis tool. For serious data work, Pandas is the better choice. Thanks for watching this Urban Flow Lab video. If you found this helpful, please subscribe to the channel, give this video a like, and leave a comment telling us whether you use Excel or Pandas for your data work. In our next videos, we will be diving into practical Pandas examples using real engineering and drainage data. See you in the next one.